All right, let's talk about a disease that is, well, hiding in plain sight. It's a massive global killer, but I'm willing to bet you've probably never even heard its name.
So we're going to start this story not with a complicated medical term, but with a number. Just a number. But it reveals the absolutely shocking scale of this invisible threat.
89,000. Take a second to let that sink in. That's not just some abstract statistic. It represents tens of thousands of real people, real lives lost every single year. But to what? And that is the absolute key. This huge number, 89,000 deaths, is the estimated toll from just one single type of bacterial infection. An infection that, just happens to live in soil and water all over the world. To really put that into perspective, 89,000 deaths a year means this one infection kills almost as many people as measles, and it kills nearly 9 times more people than dengue fever. And yet, how often do you hear about it? It gets just a tiny fraction of the attention. And here it is. The disease is called Melioidosis. It's caused by this bacterium with a mouthful of a name, Burkholderia pseudomallei. Think of it like a silent predator, just living there in the very ground beneath our feet in huge swaths of the planet. So, if this thing is everywhere, where exactly is it? Well, the official maps, they tell one story, but the science, the environmental data, it tells a much, much bigger one. Let's take a look. Okay, so this first map shows us where melioidosis cases have been officially reported and documented. You see those hotspots, right? Southeast Asia, Northern Australia, a few other scattered reports. This is the world as we thought we knew it. But then, look at this next map. This shows something totally different. This shows all the places around the world where the conditions, the right temperature, the right soil, the right amount of rainfall, are perfect for this bacterium to just live and thrive. All of a sudden, the potential threat looks enormous. And when you put all that data together, you see the true scale of the problem. This final map shows where scientists believe melioidosis is likely a major problem, but it's being missed. It's underreported or not reported at all. We are talking about a massive, hidden epidemic stretching across South Asia, Africa, and Latin America. So we've seen this giant, hidden health crisis that hits rural, tropical regions the hardest. But what does that actually mean for a person who gets sick? You see, the fight against melioidosis is won or lost on the ground, and your chances of survival often come down to one simple thing: where you happen to live. These two studies tell such a powerful story. On the one hand, you have Darwin, Australia, a place with great resources. There, melioidosis is mostly an opportunistic infection. It hits adults who already have risks like diabetes, and with top-notch care, the death rate has dropped to just 6%. But then you look at northern Cambodia, a resource-limited area, and it's like a completely different disease. It's a major killer of children, often linked to malnutrition, and the death rate is still tragically high. But here's the thing. Even in these really tough settings, there is so much hope. The study in Cambodia showed that over 10 years, they saw a huge drop in severe malnutrition among the kids who got sick. That means better public health is making these children stronger and more resilient. And check this out. The number of kids who actually finish the entire very long 12-week treatment course has climbed dramatically. This is huge. It shows that with focused effort, you can improve even really complex long-term care and save more lives. So, why is this disease so incredibly deadly, especially in places without a lot of resources? It really all boils down to one critical bottleneck: getting the diagnosis right and getting it fast. Here's the crucial point. Melioidosis is known as the great mimicker. It can look like pneumonia. It can look like a simple skin infection. It can look like sepsis. Its symptoms can look like pretty much anything. So you can't just guess. You absolutely have to have a lab test to confirm it. And that's where the race against time begins. See, the gold standard for diagnosis is to actually grow the bacteria from a sample in a lab, and that can take 2, 3, sometimes even more days. While you're waiting for those results, a doctor might prescribe the usual antibiotics. But here's the catch. This bacteria is naturally resistant to a lot of them, so that delay, combined with the wrong medicine, it can be an absolute death sentence. This delay in diagnosis has been the biggest hurdle for decades. But now, finally, new technology is here that could completely change the game. So let's just quickly walk through the old way, right? You take a sample,
maybe some pus from a skin infection. You send it off to a lab. You wait for 2 days, maybe more. Then you get the result and have to try and track down the patient who might have already gone home to finally start them on the right medicine. It's just so slow and inefficient. Now, forget all that. Compare it to the new way. You take the same sample, but you use a simple rapid test. Think of it kind of like a home COVID test or a pregnancy test. And bam, you get a result right there, on the spot, in minutes.
The impact of this is just staggering. I mean, look at this. A study in Cambodia found that with the old culture method, it took a median of 118 hours. That's almost 5 full days to get patients on the correct antibiotic. With the new rapid test, just 14 hours. We're talking about going from days to hours. That's not just an improvement, that's a revolution.
And you might be wondering, okay, it's fast, but is it accurate? Well, you bet it is. The study showed it has over 90% sensitivity, which basically means it's great at catching the disease if you have it, and 100% specificity. That means it never gives a false positive. It is a genuine game changer, especially for places that don't have big fancy labs. So we have this massive hidden killer out there. But we also have these incredible new tools and a much better understanding of how to fight it. So what does the future hold? So let's just boil it all down. Here's what we know. Melioidosis is a huge, neglected global threat. Getting the diagnosis right and getting it fast is absolutely the most critical factor in whether a patient lives or dies. For years, this was a massive obstacle, but brand new innovations like these rapid tests are finally giving doctors and nurses the tools they need to win that race against time. We know what this disease is. We know what causes it. We have antibiotics that actually work, and we now have tests that can diagnose it in minutes instead of days. And all of that leaves us with one final, really important question to think about. Why is it that in a world with so much medical innovation, the diseases that primarily affect the world's poorest people are so often left in the dark?